Okay, y'all, so we're on section 2.5 today, so we're doing more solving. So this time we're solving with absolute value expressions. So remember, absolute values look like this. So we have this absolute value. And so just like everything else, so step one here is to make sure that the absolute value expression is isolated. It needs to be all by itself. And so this is an example right here of an isolated absolute value. The only thing that I have on this side is just x. So when we get to some of these on the other side, you're going to see that there's more things happening on one side of the equation. But number one is it always has to be absolute value of x. Now, it could be that there are things inside the absolute value, like on number 3. That's okay. But number one is you got to make sure it's by itself. Okay, and then step 2, and this is the most important step with an absolute value. In fact, I'm going to highlight it because it's so important. So what happens is we have to set the inside equal. So we're going to set this equal to a positive and a negative number. And so let me show you why. So if I have the absolute value of -7, we would say right off the bat that the answer to this is just 7, right? So we take the positive, because remember the absolute value is the distance away from 0. So we don't care if it's positive or negative, we just want to know the distance. But if we look at this the other direction and we have an x on the inside and we want it to be 7, well, we don't know. We don't know what this value is. This value might be 7 or it might be -7. So that's what happens here. So when I have the absolute value isolated and it equals a number, at this point we make the positive and we make the negative. So the positive value of this is going to be 2 and the negative value of this is going to be -2. So when we write the solution, we would say x equals, now I'm going to use a brace. And this brace just means the value is inclusive to that solution. So when we use braces, so these are braces, it means only these values. Okay, so I would write this from least to greatest. So I would say -2 to 2, and that's my solution. All right, so if we go back up here to our steps, so we set them both equal. The next thing that we're going to do is we're going to solve for both equations. One like number 1, there's nothing to solve, right? We just make a positive and a negative. And then we write our solution as a solution set. And that's where we have these braces, like you see right here. Okay? So if we look at one like this, we just take this value, we make a negative side and a positive side. So this would be m equals -14 and 14. All right? M is my variable on the inside, so that's why it's m equals, and then I have the positive negative. So super easy. Okay. So let's go down here where we've got one that has something else going on. So if I look at this, this is isolated. So this is isolated, and that's because it's only the absolute value. That's all we have. So this is good. So what I have here is 5z equals 40, and I'm going to have a negative side and a positive side. So the way I write this is 5z equals -40, and 5z equals +40. All right, so let's go back up here and look at this one. So with this one, we just took and made a positive side and a negative side, right? So we took this value and we made it positive and we made the negative value here. So that's what we're doing here. So I take this and I make my solution, this part of it, a -40 and a +40. So here this tells me that z equals -8, and then this one is z equals +8. So my solution set is -8, +8. All right, so let's look at this next one, number 5. So here, this is isolated. All I have on the left side is the absolute value. I know there's stuff on the inside, but that doesn't matter. So I'm going to make my negative and my positive. So I have d plus 1 equals -8. Now, when we make this negative side, it's okay to get rid of the absolute value at that point. And over here, I have d plus 1 equals +8. So now I'm going to solve this like a normal equation. So if I subtract 1 from both sides, I have d equals -9. And I subtract 1 from both sides here, and I have d equals a +7. And so in an example like this, it's not the same value. So you can't assume it's going to look like number 1 or number 3, where it's just a positive and negative value. So here I would have d equals -9 to +7. Okay, now this is super easy to check because what happens is if I take this and bring it over here, what I have is -9 plus 1 equals 8. So this gives me -8 equals 8, and we know that the absolute value of that is positive. So we know that this one's good. And then the next one that I have is 7 plus 1 equals 8, so I have absolute value of 8 equals 8. So that's good too. So you can always take whatever your solution set is and you can plug it back into the original equation. Okay? All right, pause the video and I want you to do 7 and 8. Okay, so I just worked these as well, and so I have my negative, my positive, so I get n equals -9 to 8. And then over here, I have v equals -11 and 6. So I'm going to post this video to Schoology, so if you're not tracking on this, make sure you log in and get back to this so that you can see all the steps. Okay, let's flip it over. And now we're going to add a little bit of complexity to this. So, and that's what this says over here. So what happens if there's stuff outside the absolute value bars? So number one, most important thing is we have to isolate the absolute value. So we have to do this. So if I look at this problem is not isolated. And the reason it's not isolated is because I have this +2 right here. So the first thing, before I make a positive and a negative, the first thing that I have to do is get rid of that 2. And this gives me that the absolute value of C equals 10. So now, at this point, I'm going to change my colors right here. At this point, it's now isolated. If you separate this out and do positive and negative right away, you're going to get the wrong answer. So it's important. And at this point, I have a negative and a positive value. So C is going to equal -10 and 10. All right, let's look at 11. So on number 11, what happens is I have this 6 on the outside. So this is not isolated because this value 6 is on the outside of the absolute value. So I have to divide both sides by 6 to get x isolated. So this gives me absolute value of x equals 4. At this point, you see you have a negative and a positive side. So x equals -4 and 4. Okay, I'm going to do one more and then I'm going to let you practice it. I'm going to do number 13. So 13 is one of those ones where it's a little tricky because this whole numerator has this denominator of 6. So this is not isolated because the 6 is on the outside of the absolute value. So step 1, 2w minus 4 equals 18. So remember, when I have 6 in the denominator, I'm going to multiply this side by 6 so that it cancels, which means I have to multiply this side by 6. All right, so now I have 2w minus 4 equals -18, and 2w minus 4 equals a positive 18. So I can solve it here. So I have 2w equals -14, and this one's going to be 2w equals 22. So I'm just going to skip a step here. I would divide both of these by 2, so what I'm going to get is -7 and positive 11. All right, you go ahead and we're going to throw a fraction in there. So you go ahead and do 15 and 16. Pause the video and then pop back on so we can talk about an important one. Okay, I went ahead and decided I was going to do number 16 live so that you could walk through your steps in case you got the wrong answer. So here, of course, we're doing reverse order of operations. So you have to move the 6 first. Have to move the 6 first. It's not connected to the variable. Then I have to divide by 7. All right, so let's go over here. So if I look at number 16, this is not connected. I have to move this first. So I'm going to have a positive 24 over here that I'm going to add to both sides. So I have 3/2 of 4r minus 4, and that's going to equal 3. Okay, and then at this step, I have a fraction. So to clear this fraction, I have to multiply by the reciprocal. So I multiply both sides by the reciprocal over here, and this gives me 4r minus 4 equals The 3's cancel, 2. So this was actually an easy problem because all of my numbers canceled out. All right. So at this point, I have my negative and my positive sides. So 4r minus 4 equals negative 2, and 4r minus 4 equals positive 2. So when I move this over, I add 4 to both sides, and I have 4r equals 2. And this one is going to be 4r equals 6. Okay, so now I divide both sides by 4. And what you're going to see, I'm going to write it up here because I'm kind of out of space, is that I have r equals 2 over 4 and r equals 6 over 4. All right, so yes, you can end up with fractions. It's okay. These are not reduced though, so I have to reduce these. So r is going to be 1/2 and 3 over 2. And that's my answer. So remember, just like when we were solving normal equations, you might end up with fractions, and that's okay. You can have a fraction. All right, so we have these special cases. So what's important to remember is that if you have an absolute value, this is always, always positive, right? So we take the absolute value, and the solution has to be positive. So if I have a negative number on the inside, then I still end up with a positive value. So what we have here with these couple of special case problems is, this is saying, solve the equation below. So here I have the absolute value of x equals negative 6. Well, I can't break this out, and I can't say that there's some number on the inside that's going to be negative 6. Because if I have negative 6 on the inside of an absolute value, it's a positive 6. So there's no solution. No solution to this problem because there's no positive absolute value that can ever give a negative number. So no absolute value can give a negative solution. All right, so if we look at this one, number 18, so first step here is to isolate the absolute value. So that means I'm going to divide both sides by negative 3. So this gives me 2x plus 1 equals negative 7. Well, guess what? It equals a negative value. So this is another case where I have no solution. Now, here is the tricky part. And this is the thing that I need you to hear because this happens every single year. I can technically solve this, right? You have to recognize this at step 1. Because look what happens. I can break this into a negative and positive, and I have 2x plus 1 equals 7, and 2x plus 1 equals negative 7. I can go in here and I can solve it. So subtract 1 from both sides, and I end up with x equals 3. And over here, I subtract 1 from both sides, and I end up with x equals negative 4. So I have 2 answers. It gives me 2 answers. I can physically get 2 answers when I do this. But if I plug it back in, it doesn't work. So let's try that. So I have negative 3 times 2 times 3 plus 1. Oops, sorry. The parentheses are all messed up here. But if I solve this, I have negative 3, and I have 6 plus 1 equals 21. So negative 3 times 7 equals 21. Well, this gives me negative 21 equals 21, and this is not true. This is not true. So, again, that's the advantage. If you've got time and you go back and test them and make sure that they work, but the key here is when you have a negative answer outside the absolute value bars, it'll allow you to solve it, but your solution's not going to be right. So, what you have to do is you have to key on this fact right here. So a negative number cannot have an absolute value. All right. Okay, I'm going to go ahead and pause this. Actually, I'm going to go ahead and end this video and allow you to do a little bit of practice, and then we'll come back and look at the next lesson.